So we have two quadratic functions, and for both of these functions we need to find their xy intercept, we need to find their domains, their vertices, and maximum and minimum value or minimum values. So let's start with function f of x. So for f of x, we will do part A first. We will find the intercept. So to find y-intercept, we let x be 0. So we just substitute 0 for x in our function. So we find f of 0 equals 0 squared plus 4 times 0 minus 14. And this equals 14. So we get that y-intercept is point with coordinates 0 and 14. Now for x-intercept, we let y be 0. So that means that x squared plus 4x minus 14 equals 0. Now we just need to solve this quadratic equation. We use the quadratic formula, so x equals negative coefficient in front of x, so negative 4 plus or minus the square root of b squared, so 4 squared minus 4 times 1, the coefficient before x squared, times negative 14. And this whole thing is over 2 times coefficient in front of x squared, so times 1. Now let's do the calculation. So x equals negative 2 plus or minus 3 times square root of 2. So that means that x-intercept, we have two x-intercepts. The first one is negative 2 plus 3 times square root of 2 and 0. And the second one is negative 2 minus 3 times square root of 2 and 0. Well, now let's find the intercept for function h of x. So h of x part A. To again, I'll just copy paste the function so we can see it. Here. So to find y-intercept, we let x be 0. That means that h of 0 equals negative 0 plus 5 squared plus 2. 0 plus 5 is 5. 5 squared is 25. So we get negative 25 plus 2, which is negative 23. So y-intercept is 0, negative 23. Now let's find the x-intercept. Again, for x-intercept, we let y be 0. So y is 0. That means that negative x plus 5 squared plus 2 equals 0. Now let's subtract x plus 5. Let's add x plus 5 squared to both parts, and we get x plus 5 squared equals 2. So that means that x plus 5 equals plus or minus square root of 2. So we get that x is equal to plus or minus square root of 2 minus 5. So we get two x-intercepts. The first one is square root of 2 minus 5 and 0. And the second one is minus square root of 2 minus 5 and 0. Great. Now we need to find the domain of both functions. So for function, let's write it here, domain. So for function f of x, so the domain is a set of values of x which we use in our function, and the domain for the function f of x equals x squared plus 4x minus 13 has a real value and no x value is excluded. So the domain of this function, the domain of d of f of x, equals the interval from negative infinity to infinity. Similarly, for h of x, also the domain contains all real numbers and no value is excluded, so the domain equals the interval from negative infinity to infinity. So part B. In part B, we need to find the vertex. So again, we will start with f of x. I'll copy paste the function. Where is it? Right here. Here. So to find the coordinates of the vertex, we can use a formula. So x of the vertex equals minus b over 2a, where b is a coefficient in front of x and a is a coefficient in front of x squared. So here we have b equals 4, a equals 1, so we have 2 here. That means that x coordinate of the vertex equals negative 2. And now to find y coordinate, we just need to find f of negative 2, and that is negative 2 squared plus 4 times negative 2 minus 14. And this is equal to negative 2 squared is 4 minus 8 minus 14, which is negative 18. So that means that the vertex is negative 2, negative 18. Well, now let's do the same thing for h of x. Again, I'll copy paste h of x. So we will use the same formula to find x coordinate. So x coordinate of the vertex equals, but before we do it, so the difference is that here h of x is not in a standard form of quadratic function. We can rewrite it in a standard form by simplifying it. So we can rewrite it as negative x squared minus 25 minus 10x plus 2. Again, let's simplify it. So h of x equals negative x squared minus 10x minus 23. Now we know that, for example, the coefficient in front of x is negative 10, so we have negative 10 here, and the coefficient in front of x squared is negative 1, so we have 2 times negative 1 here. 10 over 2 is 5, so we get negative 5. Now to find y coordinate, we find h of negative 5, which is 2. So the vertex is negative 5, 2. And now we need, the last part is we need to find maximum and minimum, or minimum for the function. So part C. How to do it? So from the standard equation of parabola, if if coefficient in front of x squared is positive, so if a is more than 0, then parabola, so the graph of this function opens up. So basically our function looks like this, and its vertex is right here. So we can see that the vertex is minimum value, is a minimum value. But if a is less than 0, then our parabola opens down. So it basically looks like this. and its vertex is right here, and we can see that it's the maximum value. So here the vertex is the maximum value. A maximum value. So that means that, for example, for f of x, again, let's copy paste it. For f of x, the coefficient in front of x squared is 1, so a equals 1. That means that a is positive, and that means that the vertex is a minimum value. So the minimum value of this function is -2, -18. It's minimum value. But for function h of x, again, let me copy paste the standard form of h of x. Oh, okay, right here. So for h of x, a equals -1 because the coefficient in front of x squared is -1. So a is negative, and that means that the vertex is a maximum value. So our vertex -5, 2 is max value.